Hello children, today we will start with new lesson, that is periodic classification of elements, that is your fifth lesson in your textbook. Now what do you mean by classification of elements? What is the need for us to classify the elements? You must have seen whenever you go to a medical shop and ask for a medicine with the prescription, they will be immediately giving you the medicine from one of the shelves. That means they have arranged in a particular manner, isn't it? They have arranged in a sequential manner so that easily they can take out any medicine you ask. Same way, when we were having many elements, you know that we have almost 118 elements discovered by now. In that 98 are naturally occurring, other are scientifically made. But we have 118 elements. Now, when we got this many elements, there was a need for us to arrange them in a sequential manner so that easily we can understand the properties of the elements. Now, this is how to arrange it. What can be the criteria we have to adopt in arranging the elements? The first attempt was done in 1829. The German scientist, his name was Dobrynyi. He understood that the elements have similarity in certain properties. And at this time, that is in 1829, everyone knows that atom exists, matter is made up of atom, and atom has some property named atomic mass. Every atom is having certain mass. They were not knowing about the property named atomic number. Only mass is the criteria they used. At that time, when Dobrynyi was making this classification of elements, there were only 30 elements discovered. Now what he did is, he arranged 3 elements in a group. And he took the criteria of atomic mass. Once again I am focusing on that. And all the 3 elements he arranged. Suppose he arranged A, B, C. These are the 3 elements in the increasing order of atomic mass. Increasing. A will have less, then B, then C, like that. Increasing order of atomic mass. Then what he said, he made this as a triad. He gave the 3 elements which are arranged in increasing order of atomic mass as one triad. And what he said is, the atomic mass of B, atomic mass of element B is equal to the average of atomic mass of A and C. Once again I repeat, atomic mass of B is equal to average of atomic masses of A and C. So this is the way he arranged. To get into more detail, we can take one triad example. Let us take the example of lithium, sodium and potassium. Lithium, sodium and potassium. The mass of lithium is 7, 23 and 39. We'll see whether Dobrynyi's law of triad is followed here. Okay. Now, we have to take average of atomic mass of first element and third element. That means 7 plus 39 by 2. Average of atomic masses of first element and third element. 7 plus 39 by 2. How much? 6. 46 by 2, and that is 23. So this forms one triad. So what is this triad means? Atomic mass of second element is equal to average of atomic masses of first element and third element. Likewise, he could arrange 2-3 triads. Okay, only 2 or 3 triads, but he couldn't arrange more than that. he couldn't arrange all the elements those were discovered at that time in the form of triads. That condition was not getting satisfied. So that was the limitation of Joubrene's triad. So what is law of triad, children? Once again I will explain. Once again I will state that law of triad. When three elements are arranged in the increasing order of their atomic masses, the atomic mass of the second element is equal to the average of atomic masses of first and third element. Okay. So based on this, many problems will be asked. For example, I'll give you one question. The question is, I'll give you a question like, suppose there are three elements X, Y and Z. Now the atomic masses of X and Y is given and you have to calculate the atomic mass of Z. How will you calculate? And it has been given that X, Y and Z are following law of triads. So what is the method is, here what he said is the atomic mass of the second element is equal to the average of the atomic mass of first and third. This we don't know, put it as A. So 14 plus A by 2. Cross multiply, 46 into 2 is 90. 2 is equal to 14 plus A. A is equal to 92. 92 minus 14, that is 78. So this should be 78. So this is how you calculate whenever any questions based on law of triads have been given to you. Hope you understood. Okay. Now what is the limitation? What I said at that time, he couldn't arrange all the elements available in the form of triads. So it was not a complete successful attempt. And the second attempt was done by another scientist. He is an English scientist. His name is Newlands. Okay, John Newlands. I am going to explain the second attempt. The second attempt was done by the English scientist. His name is Newlands, and the year 1864. And he proposed a new law, that is law of octaves. So what he did is, at that time 56 elements were discovered, and whatever elements were discovered, he arranged in the increasing order of atomic mass. Okay. Now, when he arranged like helium, hydrogen, lithium, beryllium, boron, like that, he arranged in the increasing order of atomic mass. Now, when he arranged, he understood that every eighth element, suppose this is 1, 2, 3, 4, 5, 6, 7 and 8. Hydrogen, if we consider the first element, the eighth element for hydrogen is fluorine. And he understood that hydrogen and fluorine both are having similar chemical properties. If you take lithium as the first element, lithium's eighth element is sodium, and both are showing similar properties. That's the name, that's why he gave the name as octaves. Octa means 8. Every eighth element is showing similar properties like that of the first element. And for his coincidence, he understood like, if you take the notes of music like sa, re, ga, ma, pa, dha, ni, again sa. So here he just related with the musical notes, and he said, if you arrange the elements in the increasing order of atomic mass, every eighth element is showing similar properties like that of the first element. And he was successful in arranging and giving the similarities like lithium and sodium and potassium. All these were showing similar nature. Beryllium, magnesium. First element is beryllium, then magnesium is the eighth element, and both were showing similar nature. So he could arrange it successfully. But when he was arranging more and more elements, the attempt was successful till the element calcium. After that, chromium properties were not matching with aluminium properties. And when he arranged, you must have seen now here, he arranged cobalt and nickel both in same column. And cobalt and nickel is coming under the group of halogens like chlorine, fluorine, and they don't behave similar. Actually, cobalt, nickel and iron were showing similar nature. So it was successful till the element calcium. After that it was not successful, and when new elements are being discovered or introduced, this order was not coming correct. So that was a limitation or drawback of Newland's law of octaves. So once again, what is Newland's law of octaves? When the elements are arranged in the increasing order of atomic mass, every eighth element is showing similar properties like that of the first element. And what is the drawback? He couldn't arrange all the elements, or all the elements arranged were not following the similar nature, like eighth element showing the similar properties like that of the first element. And when more elements were discovered, he was not able to arrange in this manner. So that was the drawback of Newland's law of octaves. Next attempt was done by another scientist. His name is Mendeleev. So that one will be teaching you later. First you learn these two, and based on this some questions are there in the textbook. Try to solve this. Okay children, thank you.